Hello students, today we will be studying about adsorption and its type from Surface Chemistry class 12. To begin with, let us see what is surface chemistry. Surface chemistry deals with phenomena that occur at the surfaces or interfaces. There are many properties of substances, particularly of solids and liquids, which depend upon the nature of the surface. Surface represents the boundary which separates two bulk phases. So, the branch of chemistry which deals with the nature of surfaces and the phenomena that occur at the surfaces or interfaces is called surface chemistry. Adsorption on solid or on solution surfaces, colloidal properties, electrode processes, heterogeneous catalysis, dissolution and crystallization, corrosion, etc. are important surface effects which are useful to understand many physical and chemical properties of the substances. Adsorption. Let us see what is adsorption. The phenomena of higher concentration of any species at the surface than in the bulk is called adsorption. Adsorption is a surface phenomenon. Even surfaces of liquids also show this phenomenon. So, to define with, the phenomena of attracting and retaining the molecules of a substance at the surface of a liquid or a solid, resulting into higher concentration of the molecules on the surface than in the bulk, is called adsorption. As a result of adsorption, there is decrease of surface energy also. But right now, let us differentiate between absorption and adsorption. Absorption is assimilation of molecular species throughout the bulk of the solid or liquid, whereas adsorption is accumulation of the molecular species at the surface rather than in the bulk of the solid or liquid. Absorption is a bulk phenomena, whereas adsorption is a surface phenomena. Absorption is endothermic process, whereas adsorption is an exothermic process. Absorption is not affected by temperature, whereas adsorption is favored by low temperature. Absorption occurs at uniform rate, whereas adsorption steadily increases and reaches to equilibrium. In absorption, the concentration is same throughout the material, whereas in adsorption, concentration on the surface of adsorbent is different from the bulk. It is more on the surface. Let us see some important terminologies like adsorbent, adsorbate, desorption. What is adsorbent? The solid substance on the surface of which adsorption occurs is called as adsorbent. Adsorbate. The substances that get adsorbed on the solid surface due to intermolecular attractions are called adsorbate. And the process of removal of an adsorbed substance from the surface on which it is adsorbed is called desorption. It is the reverse of adsorption and can be brought about by heating or by reducing the pressure. There is one more thing I would like to tell. The phenomena of adsorption of gases on the surface of metals is called occlusion, and sometimes both the adsorption and absorption are occurring simultaneously, and the phenomena is called as sorption. S-O-R-P-T-I-O-N. Sorption. Let us see, there are two types of adsorption depending upon the nature of forces which hold the molecules of adsorbate on adsorbent. First is physical adsorption called as physisorption. The second one is chemical adsorption or chemisorption. Physical adsorption and chemical adsorption. Let us differentiate between them. Physical adsorption is caused by intermolecular van der Waals forces. The forces between adsorbate molecules and adsorbent are weak van der Waals forces, whereas the forces between the adsorbate molecules and the adsorbent between in chemical adsorption are strong chemical forces similar to chemical bonds. Physical adsorption is not specific in nature. That means all gases are adsorbed on the surface of a solid to some extent. Whereas in chemical adsorption, it is highly specific in nature and occurs only when there is bond formation between adsorbent and adsorbate molecules. Physical adsorption is reversible. Chemical adsorption is irreversible. The heat of adsorption or the enthalpy of adsorption is low in physisorption of the range of 20 to 40 kJ per mole, whereas in chemical adsorption, the high heat of adsorption is found of the range 80 to 240 kJ per mole. Low temperature is favorable in physisorption, whereas high temperature is favorable in chemisorption. Physisorption forms multimolecular layers because of the weakest van der Waals forces, and chemical adsorption forms monomolecular layer. Also, I would like to tell, the rate of physical adsorption increases with increase in pressure of adsorbate, whereas rate of chemical adsorption usually decreases as the pressure increases. Let us see the factors affecting adsorption. First, effect of adsorbate or the nature of the gas. The easily liquefiable gases like ammonia, HCl, CO2, etc. are adsorbed to a greater extent than the permanent gases such as H2, O2 or N2. Also, higher the critical temperature of a gas, greater is the amount of that gas adsorbed. Effect of specific area of the adsorbent. The greater the surface area or the specific area of the adsorbent, that is the surface area available for adsorption per gram of the adsorbent, the greater would be its adsorbing capacity. Effect of temperature. Adsorption decreases with increase in temperature because adsorption is an exothermic process, and as per Le-Chatelet principle, it will decrease with increase in temperature. Effect of pressure. An increase in pressure causes an increase in magnitude of adsorption of an adsorbent. So, decrease of temperature and increase of pressure both tend to increase the extent of adsorption of a gas on a solid. Lastly, let us see the application of adsorption. There are many applications of adsorption, whether it is in gas mass, in catalysis, or in adsorption indicators, in softening of hard water, in paint industry, or even removing moisture from air in the storage of delicate instruments. I hope you all have learned adsorption and its type very well today. Thank you.